I would like to welcome everybody here at the conference, but I'm going to be an exception because I will speak in English, although I'm Hungarian.
First of all, please allow me to convey the best regards from the Hungarian Energy Office and the President of the Hungarian Energy Office to the members, participants of the conference. It's a great pleasure for me to share a couple of thoughts about the Hungarian smart metering and smart grids preparation situation. The electric energy industry is facing the challenges of basic changes. The place and way of production is forcing a change at the distributors to enable integrating the renewable energy into the system and by the spread of the distributed power production. Smart metering systems and smart grids are the instruments for the DSOs and TSO to cope with this new challenge. The future vision is that the customer will directly influence the system, optimizes his own consumption, and will act in many cases as a producer as well. Basic instruments for this are the smart metering system, which provides all selected information to the customer, generator, supplier, and distributor, enabling them to optimize their operation technically and economically. A smart grid can be described as an electricity network that can cost-efficiently integrate the behavior and actions of all users connected to it, generators, consumers, and those that do both, in order to ensure economically efficient, sustainable power system with low losses and high levels of quality and security of supply and safety. Some benefits of the smart metering system, smart grid system: energy saving driven by the customer awareness and economical interest, improving power distribution system control and system reserves, effective and controlled information data flow, enabling technical, economical, and market optimization, reducing peak load level, this is a part of the system optimization, enabling the integration of small renewable energy and cogen power plants in the transmission distribution system, an opportunity and technical instrument for transportation electrification and the e-mobility. Here we see some players of the smart system, actually the big power plants, renewable power plants, distributors, consumers. On the right upper side, a house or an office building where somebody is producing energy and consuming also energy, a wind farm, some consumers, e-mobility, and the central control center of a DSO. One smart metering system structure sample we can see on this slide. Actually, this is mixed now. We have Hungarian letters, Hungarian words also on it. Anyway, on the left upper side, there is the consumer, who is the customer. Below him, we see the meters. We see electrical meter, gas meters, water meter. It can be also district heating meter. It's important that the customer is having a display. Different technical solutions are, one of them is that the display is on the meter, other one with some kind of internet connection. Anyway, the customer can see a lot of data from his consumption. Then these data go to a data concentrator and with a GPRS system to the DSO data process center. On the lower corner, a direct connection with GPRS also to the DSO central, and then the data are processed at the data process center at the DSO, and selected data will be delivered to the different utilities: gas, water, district heating. And here on the right side, on the right lower corner, there is also an invoicing system connected to this data central. Preparations for the smart metering and smart grid in Hungary. The related legislation in Hungary is based in several aspects on the EU directives and regulations. EU directives request the member states to ensure the implementation of intelligent metering systems. The implementation of those metering systems should be subject to a preliminary economic assessment to evaluate if the intelligent metering is economically reasonable, cost-effective, and in which time frame is feasible for their distribution. For this assessment, pilot projects shall be run to supply practical data for cost-benefit assessments, to distribute the costs and profits among the players of the value chain, and to choose the optimal tariffs. To determine the technologies, the requirements and standards for metering and telecommunications. To answer data management and protection questions, it's a very important issue. We know that, for instance, in the Netherlands, it took 2 years until the legislation solved that problem, and they could introduce the smart metering. Study the behavior and incentive possibilities for the customers, and to form the legal framework. The Hungarian Energy Office established and operates a smart metering working group, the members of which are selected from a broad range of industry players: electricity, gas, district heating, water distributors and suppliers, universal suppliers, system operators, traders, consumers, representatives of the ministry and of the science. The initial task of the working group are to prepare the requirements, the conditions and the assessment method, and the kickoff of the pilot projects. Longer-term task is to prepare the proposal for the rollout in case of a positive decision. The Hungarian distributing companies started their smart metering pilot projects in June 2012. The DSOs developed their own internal rules on the pilot projects, began procurement processes, started technological developments on telecommunication solutions and data management, selected customers for the pilot, and started to install smart meters at the customers' premises. Some pilot projects are multi-utility models, including, beyond electricity, natural gas, water and district heating metering as well. It's important to mention that the technical solutions of the DSOs are also different. So we will have a broader range to evaluate which solution could be good for the future. The Hungarian TSO, Mavir, announced also a plan about conducting a smart meter, smart grid pilot project in the near future. Next steps. To continue the pilot project, to gather all necessary information, evaluation all the data available from the smart metering pilot projects, to conduct economic assessment of all the long-term costs and benefits to the market and to the individual customer, to determine in which form can the smart metering economically reasonable and cost-effective be introduced, and which time frame is feasible for the rollout. Recommendation to the legislation about the way and conditions of introduction, and extension of the studies and pilot projects in the direction of smart grid. And thank you very much for your attention. Köszönöm szépen.